Hello and welcome to our PTV Talk session today. My name is Jongsun Won at PTV America office in Arlington, Virginia, and I will be your host today with Betsy LaRue here with me. If this is your first time at PTV Talks, here is what PTV Talks is.
PTV Talks is a series of regularly scheduled web sessions that we have launched in response to our clients' request for additional content and as a way to deliver product information, use cases, and educational information out to our users. Throughout this series, we will have our PTV staff, PTV software users, and other industry professionals presenting on various topics in various formats. We would definitely like to have your feedback on what type of content you would like to see, so please feel free to submit any requests or comments to info.us@ptvgroup.com. Also, if you would like to catch up on any of our previous sessions you have missed, please visit www.ptvtraffic.us and go to the Resources tab where you can find recordings of the past events.
The title of today's PTV Talks is Hot Seat with PTV Vissim Development Team. Before we get started, we would like to talk about what a hot seat is. If you have attended our user group meetings in the past, this will sound familiar to you. At each UGM, we always have a hot seat at the end where we open up the floor to our users to ask questions and future requests to the development team. Since UGM happens only once a year, and we would like to have more opportunity to have our users to ask questions and future requests, like live conversation with users, we wanted to utilize PTV Talks for that purpose. Today we have Lucas Couch, Jochen Lohmiller, and Adam Lynch from our Vissim product management team at our headquarters in Karlsruhe, Germany.
Since we wanted to have a little bit of structure to this, we have reached out to some of our power users to see if they have any features that they would like to request. Luckily, we had quite a few volunteers. Today we'll hear from Joe Blasi with HNTV, Dave Stanek with Fair & Pierce, Randy Johnson with DKS Associates, Mike Forsberg with HDR, and Gustavo Sabalos with Recondo.
Here is a rule for today's hot seat. Each presenter will get about 5 to 7 minutes to present their request. Once presentation is done, product management team can ask questions for clarification. Then presenter will get a chance to respond, and finally product management team will get a chance to add anything at the end if needed. After that, we will proceed to the next presenter.
With that, we would like to welcome our first presenter, Joe Blasi.
Joe, we're going to unmute you here.
Hello, can you hear me?
Yep.
All right. Well, good morning, good afternoon, depending on where you are. Let's see, can you see my startup screen here with an interstate, some traffic?
We can.
Okay, excellent. Okay, so I just have a few minutes here today, and I wanted to share a thought about lane change distribution. And I think this is something that's been discussed. I think probably a lot of you have thought about this, but I was hoping to move it up on the PTV wish list. So as a background, I've noticed at times that I've had difficulty calibrating one of my freeway models upstream of a high volume off ramp. And so part of the reason for that is when you have an off ramp and you code in a lane change distance upstream of that off ramp, I believe the default distance is 200 meters or about 656 feet. At that point, upstream of the ramp or of that connector, all vehicles will start initiating a lane change to try to position for that off ramp. And what I've found is in some cases at that point, 656 feet upstream or whatever I've changed it to, I would see a lot of congestion in the Vissim model, which is not necessarily representative of what's going on out in the field. because out in the field, people initiate their lane changes at different times. Some I'll call them granny drivers, might start their lane change a few miles upstream of a ramp, and some more aggressive drivers might wait until they're almost past it before they start their lane change. And so I thought, is there a way that we can model this within Vissim? So I've tried throughout the years some workarounds by putting in dummy connectors into the network and routing certain percentages of my vehicles through these dummy connectors to try to spread out the lane changing. But I had another thought on maybe a better way to do that. So currently in Vissim, there are already several distributions out there. There's dwell time distributions, there's speed distributions, and there's even, as I was preparing for this, I didn't know this existed, but there is actually a distance distribution feature. And so my thought is, could we create a distance distribution feature that would be used for lane change distances? So you could define a curve, something like what you see on the screen now, where a certain percentage of vehicles would begin their lane change at a certain distance upstream and others would start later on. And maybe that could be based on the aggressiveness of the vehicle, not knowing exactly how the coding works in the background. I'm not sure how that might play out, but possibly by the aggressiveness of the vehicle. And so taking that to the next step, when you click on your connector, and today you would go in and down near the bottom of the window there where it says lane change, I often change my lane change distance to about a mile instead of the default 656 feet. But perhaps instead of just putting in a single number there, you could have a pull-down menu where you could select a distance distribution for that. Or perhaps there could be a couple of fields there, and you could define a normal distribution where you would define an average or a mean distance, and then a standard deviation distance to define that distribution. And then I threw in there, it might even be, it would give you even more control if you could assign those distributions based on vehicle class. So for instance, a truck might initiate a lane change earlier than a passenger vehicle would. So you could set it up like that. And then down at the bottom here, I put another idea of what this maybe could look like in a list form, where you can make a list where you define your vehicle classes, your cars, your trucks, whatever else. You could have a couple of columns to use if you were doing a normal distribution, where you'd put your mean and your standard deviation. Or you could have a checkbox that says, I don't want to use a normal distribution, I want to use a custom distribution, and that would pull from one of your distance distributions that's defined elsewhere within Vissim. And then I would still keep in the lane change distance per lane feature that currently exists. So with that, there's some thoughts. I guess I'll take any questions from the development team.
Development team, any questions or clarification that you need?
Well, not really questions, I think. This idea has been brought up several times, and just using distributions like and it wouldn't matter if it's normal distributions or user-defined ones would hurt performance a lot if we did it just well, the simple way, making each vehicle actually looking ahead and calculating its own well, the distances each time on its current route. The problem is that all those of the downstream connectors are kind of overlaid and saved for, well, for all vehicles on a route. So we would need to do something differently there. Well, maybe I have one question, but I'm sure Joe did that anyway. I assume you have modified the accepted decelerations if required. You know what I mean in the driving behavior.
Driver behaviors. Yes. Yes.
Well, if the lane change distance is, well, a mile, that doesn't necessarily mean that all vehicles immediately change lanes there, but, well, they accept deceleration from the trailing vehicle on the new lane according to the settings in the driving behavior. And that, for example, you might set that value to 0 or very close to 0 for the full distance, which means it would basically only change to that lane if it does not make anyone brake even a little bit, and then you could modify that then that accepted deceleration would increase when coming closer to the well, emergency stop position. But I assume you did that already accordingly, and I think the second way you suggested that it might be somehow related to the vehicle class, or, well, to the then maybe to the driving behavior. That might be an option, and it might be possible that we put some, say, modification of the normal lane change distance there. So a way to kind of define for a driving behavior how that normal lane change distance is modified. I have to think about that, but that is definitely an easier option and without hurting simulation speed than having one distribution for each connector, which is actually well, that's the problem. Then you have basically you would have to fold all these distributions backwards, and that's tricky. Yeah, so
all right.
Thank you.
Thanks so much. Thank you, Joe. We're going to move on to our next presenter now. So we'd like to welcome Dave Stanek.
Hello, everyone. This is Dave. I'm with Fair and Peers, and I'm based in Sacramento. Let me share my screen here. How does that look? Can everyone see my screen okay?
Yep, we can.
Yep.
All good.
Cool.
Thanks.
All right, great. So I have one main item to talk about, and then a quick one that I came up with as I was preparing for this talk today. So the one that I want to talk about is driving behavior and the lane changes again. In this case, what I want to do is talk about the the adjacent lanes, and essentially the lane changing is restricted to adjacent lanes only. And I'm often working on multi-lane roadways or multi-lane freeways where operations in some lanes are a lot better than others, and vehicles can kind of get stuck behind queues in lanes on the right when lanes on the left are operating a lot better. Essentially, the vehicles that are in the right lanes can't see the operations that are happening in the left lanes. And again, this is really a problem when you have a queue like in the middle lane potentially, or even on the right lanes, and vehicles are kind of stuck on the right and they can't see to change lanes because their adjacent lane is traveling worse than the current lane they're in, but they can't see that maybe the leftmost lane is free flow conditions. So this often happens on freeways that I'm working on in California, where we have managed lanes or carpool lanes in the left lane that are continuous access. So there isn't a specific point where vehicles have to merge over to use the lane. They can choose to use the lane at any point. Because of that, we have less vehicles in that restricted use lane compared to other lanes. So when we get to bottlenecks, vehicles in that lane can pass by that bottleneck at a higher rate of speed than the other lanes. So what's happening in Vissim, and here's a model of that, you can see the southbound lanes are congested, and the leftmost southbound lane is a managed lane, carpool lane in this case. All the pink vehicles are carpool lane eligible vehicles. And you can see that in that green lane that's highlighted based on it being the carpool lane, a couple of carpool vehicles in it. But there are also vehicles that are in the right lanes that, again, are stuck in the queue. And because they can't see what's happening way over to the left of them, in the model at least, they can potentially get stuck there. Now, actual drivers, of course, will know when they merge onto the freeway and they're a carpool that they want to get over, and so they will look for opportunities to change lanes and eventually merge over and use the carpool lane. I've been using some workarounds to kind of force that behavior using parallel connectors, but I was hoping that there would be a way for us to change the driver behavior in the lane change to allow for certain links where vehicles could look across all lanes to decide which lane they want to travel in, especially when we have these really, again, multi-lane freeways. So the idea here would be to add a parameter someplace in the lane change part of the driver behavior where we could allow vehicles to not just look at the adjacent lane, but look at multiple lanes on the same link. And then I guess before we'll answer questions on that or get questions on that, I had one quick request. And so the quick request here has to do with static routes. And so when we're coding static routes in a model, we need to place kind of a red bar and a green bar at the end. And when you have a really large network, say for example, this project I'm working on that's a 25-mile long freeway, it gets really tedious to place those red bars and green bars at every entry and exit point by zooming in and panning around and zooming out again. So I was hoping there would be a way for us to automatically generate routes from an entry link to an exit link. And I'm thinking of the way that in the data collection measurements, you can right click on the link and say generate all, and it automatically creates the data collection measurements from all of the data collection points. And so if there were a way for the model to automatically look at the network structure and generate the red bar and the green bars for the routing decisions and the routes, that would save a lot of time in coding some of these larger networks. And that's all I have.
All right, thank you, Dave. Product management team, do you have any questions for Dave?
Yeah, thank you very much, Dave, for this suggestion. Makes makes a lot of sense. Regarding the second, with the adding the routes, there is like the solution to convert a dynamic assignment network to a static network. So if you, well, it's also not straightforward, but if you would create a dynamic assignment network in the first place and just run one iteration on this like corridor model, and then create of the dynamic assignment network a static model, then these routing decisions will be added automatically. Yeah, but you need to go you need to do the workaround with the dynamic assignment model. Yeah.
Yeah, so the issue there would be we'd have to create all the parking lots and the nodes too, so that would be a lot of coding as well.
Yeah, but at least you don't have to connect a starting point to an endpoint. You just create the parking lots at one entry and then the parking lot at the other entry, and it will find all origin destination paths. Yeah.
Would we have to create the nodes too, or just the parking lots?
Nodes, parking lots.
Yeah, no, it's parking lots.
Well, maybe not too many nodes, just some.
Yeah.
So you wouldn't need one at each intersection. It would be perfectly fine if you say in a grid network you have one per say row of intersections or so. So that would be sufficient.
Yeah.
And then basically the parking lots for defining the entries and exits, because I'm not sure if that is easy to determine in a network which ones you actually mean. For example, you have some links ending with in the middle of an intersection, and because there's then a connector to the next link, but those are not entry or exit points. So yeah, it's I think we could find a way to find like specific positions where you have a longer stretch of road without a connector or so, and that one with an input, for example. Those are easy. The exits are the hard ones, I guess.
And I've got a couple tips as well. One for your network that you have up on the screen that's already been done and it's quite large. You could turn on the link numbers and make the size really big for the link numbers, and then just change the end decision point link to that link number, and then maybe that way at least you'll get it on the right link, and then you could change the distance either manually or just drag it. If you're starting a new model, maybe this isn't the best case, but just like a regular corridor size model, you could start it in Vistro. And actually what you do would be placing nodes on all of your entry and exit points except for one gate, and place one gate. And then when you convert with the A&M, you convert with dynamic assignment, and that will actually set up the zones, the gates, and then you just create the matrix and do what Jochen said by converting to the paths to routes. So that could be a shortcut if you're starting from scratch.
Okay.
But additionally, we're also looking at the functionality. I had in mind like, what's lupe in English? Sorry.
Magnifying glass.
Something like a magnifying glass. So if you zoomed out quite a lot, then you go somewhere and try to send another location that you get some kind of magnifying glass or something. Would that be a good solution which you could think of?
Like a second network editor window.
Well, that,
that's a potential. Sure.
Sure. You can have a second one already.
Yeah. So if you click on View, open a new network editor, you can have two network editors or three or four side by side, and then having the locations, the zoomed in locations, and creating the starting point in the one network editor and selecting the other in the. Does it work?
I think it should work.
Yeah.
Yeah, but not 100%. Need to try that.
Okay.
Okay, and your first issue, that's something we almost did, like I don't know exactly, but it was 10 years ago or so with the NGSIM research project, where we already implemented for as a prototype or so a lane selection algorithm from MIT, which did not really work really well, but the idea to have a lane selection which does not only choose from the adjacent lanes is something we really could do. And I think we just forgot about that in the meantime. And from German highways, we don't think about like 5 and 6 lanes usually, and so we just forgot to do that. But that should not be too difficult. We could just really, as you said, add that option to the driving behavior, and then the vehicle could select from all lanes, and even if they are like 3 lanes away, it would then try to get into that direction. Yeah.
All right, thank you.
All right, thanks again, Dave. We are going to move on to our next presenter now, Randy Johnson.
All right, well, thank you very much. All right, everything showing all right there?
Yep.
We're seeing presenter's view. We're seeing, yeah. You may want to duplicate probably. Yeah.
Slideshow. Sorry, 1 second here. All right, how's that?
Yep. That looks good.
All right. So I'm Randy Johnson with DCAS Associates. Thank you for the opportunity to share some of our feature requests. So we held a sort of a little internal roundtable on feature requests against our different users here. And so instead of digging down into 1 or 2 requests, I thought I'd do kind of a rapid fire of a bunch of smaller requests and maybe some not so small. So feel free to cut me off if I'm going too long here. So starting off with links, one thing that's a big source of frustration for a lot of the users, especially when building the network, is how easy it is to accidentally move links. And sometimes you don't, especially when you're zoomed way in, you don't even notice that you move it because it's as simple as just left click and drag and the links move. You could, of course, lock the link layer, but then nothing is selectable and you can't really do edits of other network elements. So it'd be nice if we could bring back the feature we had in versions prior to Vissim 6, where you have to hold down the shift key to move a link, since moving a link is not as common as all the other editing features. So that would certainly avoid a lot of frustration. And then also occasionally there's some issues with link overlap, link connector overlap, causing network elements to get missed, especially as networks are modified. So especially on straight through connections, having the ability to snap a connector to the end coordinate, end and start coordinates of links would certainly help. And then to just highlight Joe's feature request of the lane change distribution, this is something that I would certainly iterate a need for something to that effect. Reduced speed areas. A lot of times we want to have these sort of conditionally applied rather than all the time or just simply by time. So being able to add reduced speed areas is one of the options with VAP. Currently VAP will only allow you to control desired speed decisions. And then also perhaps add the ability to control the reduced speed area activity based on the signal group, signal control, and signal state, similar to the way priority rule does. So make it active based on those conditions. So conflict areas, also similar to priority rules, being able to change the ability to adjust it based on the signal state or have control through VAP. This is especially helpful when you're dealing with permissive movements at signals where, say, a left turn, when it has the protected movement, it doesn't have to yield to an opposing right turn, but when it's permissive, it needs to yield to the right turn. Of course, we could use priority rules, but it'd be nice to have that functionality with conflict areas. And then to assist with model QC, being able to visualize where any additional stop distance is applied to the conflict areas. So maybe that's visualized with a different color instead of just increasing the red, so you can see where it's been changed from the default, and then see exactly how far back that goes. Stop signs, we've had several projects lately where we really have to dial in the capacity of traffic through a stop sign. More often the case is we have rolling stops where vehicles aren't coming to a full stop. So of course we could do rolling stops using a really small reduced speed area with a low speed distribution. But sometimes that provides too high of a capacity. So being able to provide a relative percentage of vehicles that fully stop would be helpful. And then for the vehicles that don't stop, simply apply a speed distribution and have it be treated like a reduced speed area. And then signal control. Currently, once a simulation is running, you can't check anything in an RBC controller. So you have to stop the simulation to then open the RBC to make an edit or simply view it. In versions prior to 6, I don't know if this was in 6, but I know at least prior to 6, you were able to at least open the RBC files while the simulation was running. You couldn't make any changes, but you could at least see it to check some of the parameters. When you're dealing with a multi-hour simulation, especially large ones like Dave was showing, it takes quite a while to get into the simulation. If you just want to do a quick check on that particular setting, that would certainly be helpful. And then of course, a bonus feature then would be able to allow for editing of the signal timing features while the simulation is running. That would certainly allow you to do a quick check, especially if it's just a minor tweak, and then just make that parameter change active from that point on within the simulation. Then there's a handful of common controller features that we at DCAS have been using quite a bit lately. That'd be nice to have built-in controller features. These are fairly common in most controllers. They're not in RBC. There are certainly workarounds for these, but it'd be nice to just have the direct features. This includes allowing more than 4 preamps, having queue delay recovery on the preamp. So if a particular phase is skipped for X number of seconds, based on time or based on a queue connection, then have the post preemption provide a particular operation. And then here in Portland, we're very pedestrian friendly. There's a lot of pedestrian special timing features. So having the ability to do pedestrian overlaps and leading pedestrian intervals would certainly be nice. And then this one, not quite such a small request. This is more of a dream or a wish, I would say, is a central signal system. So we have this Vissim model, and sometimes we have a lot of controllers in there. Being able to kind of look at everything from a system level, similar to what a lot of the central signal system software does. Being able to define corridor groups and basically see live time-space diagrams, see the vehicle trajectories going through those, being able to tweak the offsets, see live automated performance measures, and really use Vissim as a live diagnostic tool so you can make those changes sort of on the fly and get more robust performance measures without a heavy amount of post-processing. And then lastly, a few requests on the output side. Often we want to categorize latent demand by vehicle input. Currently, this is only available in the error file. So while we have a script that can process the error files, it'd be nice to have a direct output so we could get latent demand and delay for each individual input rather than just globally with the network performance. Another big one that we generally deal with in post-processing is getting the correct percentiles. So being able to present the 95th percentile queue length, for example, while you could define percentiles in the Vissim output configuration, you essentially get the percentiles of the averages of each run, and you don't get say in that 95th example, you don't get the 95th observation of all data observations across all 10 runs. So it's not really a usable calculation there. It would also be helpful to have the multiple aggregation time intervals on some of the outputs. Often we want to have multiple time periods aggregated. So with volumes, for example, sometimes we want to check the GEH for the overall simulation period if it's a multi-hour period. But then we might also want to pull what is the peak system hour. So say if it's a 4:45 to 5:45 and we want those measures, but we also want the 4 to 6 p.m. And then lastly, the filters list on the results is extremely helpful. So that's a nice, relatively new feature. But being able to filter that even further by allowing multiple strings in that filtering. All right, so that was my rapid fire list.
All right, thanks, Randy. Product management team, do you have any questions for Randy? We've got maybe 1 or 2 minutes for questions.
Well, thank you, Randy. Not really questions. I think we understood your requests. Makes sense. So thanks for the feedback. I'm not sure if we have comments to some of the topics.
Maybe a couple comments. With larger models, I understand the concern with the connectors and trying to identify connectors and seeing longer connectors versus shorter connectors. One strategy I've used is actually just changing the connector color. You can get into the list and change the display type to maybe like a different color. And then at least that way you can see which connectors belong where and maybe there's overlaps. So that's one tip. With the lead pedestrian interval, that's something actually in Vistro we're looking at as well. And then to get that into Vissim through A&M, we're looking into how that is actually possible. One workaround on the Vissim side is actually you can set your, I guess the through movement or whatever you wanted to delay. You can set it up as an overlap with itself, which is kind of a weird way to do it because the overlaps do have delay greens possible. So basically you would just set up the through movement, say group 4, you maybe call it 40 and set up an overlap for 40 that has a parent of 4. And then in the ring, you identify 40. And that way you can add a delay green for a pedestrian interval.
Right, we have a similar workaround, just using a dummy feature to hold back for whatever the desired feature is and series of overlaps. So
yeah, but that one is on our radar because we want it to work in Vistro as well. With that, we've been getting some requests for lead pedestrian intervals there.
Okay, excellent.
And I took a note as well with the central signal system. I think again in Vistro that would actually be a really good feature to include in Vistro as well.
Right.
So
maybe Vistro could be the central signal system for Vissim.
Yeah, and we've had some talks and figuring out the workflow. Is it possible to control maybe some pattern timings through Vistro and then have that automatically sync up with Vissim?
Excellent.
All right, thanks so much, Randy. Okay, we're going to move on to our next presenter.
Can I add one?
Oh,
sorry.
Go ahead.
Yeah. Yep.
Just a quick note. Some are writing +1 on some feature in the questions, so that is very helpful. So if you find something very useful for the others who are listening, please comment using the questions button on something you really like. Yeah.
But write what you like,
yeah.
not only answer this, because well, there are many things over the time.
Yeah.
Cool.
Yep. Okay. All right. We are making Mike the presenter now.
All right. See my screen all right?
Yep, we can.
So, unlike some of the others who've prepared kind of like several slides that kind of show some different things, I just wanted to kind of keep it simple and show a few things that we've been thinking about here at HDR and similar to what Randy had done, I too kind of enlisted some of our power users within HDR to kind of ask, well, what are some things that we'd want, and kind of like what Randy found out, the list can be quite long, and I said, well, we're not gonna list 50 things because I have 10 minutes. So so I listed a few, and then while I was listening and watching the webinar, one was taken, so I added another one, and then another one was taken. So it looks like there's some good overlap and definitely some interest in some of the same things. But I'll just kind of work through the list here. So one of the first things there is, you know, on the topic of RBCs, like what Randy was talking, a couple of different items with regard to more of an updated interface, possibly. Allowing multiple RBC editors to be open simultaneously would be nice when we've got a couple of closely spaced intersections that might be tied to one controller, or even if they are separate controllers, but the timings really we want to integrate together. It'd be nice to be able to have them open simultaneously. I don't know a way that can be done with the current format of the editor. I don't know if there's a way to change that to allow for multiple editors to be open simultaneously, but that would be something we'd be interested in. Allowing the network editing while the RBC editors are open. So if I'm working in an editor, an RBC editor, I can pop back into the network, add signal heads, add detectors, be able to go back and look at what overlap numbers we've identified in the RBC. That was something that we'd like to see. Yep. Reiterate, thanks Joe, and Randy brought it up as well, the lane change distribution. I know there's some challenges there. I know I've kind of heard that in the past from PTV that it definitely does slow down some things. Maybe there's some options there. I don't know that I have another solution other than, I mean, maybe there's I know some of the workarounds where, like Joe mentioned, creating dummy links and things like that, dummy connectors. If a distribution was used, I don't know, some kind of a feature that automatically generates dummy connectors, and then we'd have to generate duplicate routes and redistribute traffic. It seems like a lot of work to be done through some kind of a built-in Vissim tool. It seems like that might be the way we have to continue to go for now, at least. But detectors, in the detector menus, we can decide where the detector is placed based on the distance before stop, but in the list view we don't see that as an attribute to be able to edit. It'd be nice to have that in the list view so that if we want to assign a set distance before the stop bar at multiple detectors, we can do that more easily in the list view. During the webinar here, I actually added the generation of vehicle routes through some kind of an embedded tool, and then David touched on that as well. Yeah, it would be nice to maybe improve upon or simplify the way in which routes are generated, either some sort of an automatic tool feature, or you know, maybe even just, you know, you open a routes tool, you select on a link for the origin, and then just start rapidly clicking destination links, and then once you're done selecting all of your destination links, it automatically generates all the routes for you, or something. So, some way to kind of you know, speed up the process to generate routes. And the last one that I added, again, while on the webinar here, was a vehicle attribute for the lane change decision type. This is something that kind of came up recently on some work we've been doing with the connected automated vehicles, and with trying to keep platoons of CAVs together. We've made a lot of scripting to handle some things and keep platoon integrity intact. But one thing that would have been a much simpler way for us to check is if we knew that a vehicle in a trailing position of a platoon were making a lane change for a downstream turn decision versus making a lane change because they were violating some form of safety distance in front of them, and we would basically say, if you're a trailing CAV, we would restrict you from making a lane change unless you are doing it for a downstream decision. That would have been one way we could have kind of simplified some of the scripting that we were having to develop to accommodate that. So yeah, again, like Randy, have some others on the list here, but in the interest of time and everyone's time here on the call, I'll just leave it with the list that I've got up here.
All right, thanks, Mike. Product management team, do you have any questions or comments?
Yeah, I was just saying, Mike, hello again.
Hello.
With the RVC, I mean, it's a workaround, but you can't open two instances of Vissim at the same time. While one is playing, you can use the other instance to view the RVC that's not playing. As far as editing and things like that, I probably wouldn't recommend it, but
you can do it, but it won't have an effect.
Okay. Lucas says no effect there.
Not in the running simulation, because the controller doesn't reread the file.
Okay.
Yeah, and I wasn't talking about during a run, but just during network editing and RVC editing, being able to edit the network.
Yeah.
Yeah, just a second instance is good.
Yeah, it's probably not the best solution, but it is a solution. I think that helps Randy's comment as well, as looking at things while the simulation's playing.
Mm-hmm.
The detector list, I agree. I mean, with the way DOTs maybe have a 2-foot overhang or something like that over the stop bar.
Yeah, and that's already on the list. I think that's even very close to the top, so there's good chance it happens soon.
Yep. You guys have comments on the other one?
Yeah, I have a question regarding that CAV modeling. You did that through COM scripts?
Yes.
Okay, yeah, because well, I thought in the driver model DLL interface there you get the information if it is a necessary lane change for a connector, downstream connector, or if it's or not. But yeah, we could add that as an attribute to the vehicle, I guess. Well, and you will find that we have the platooning options in Vissim, well, 2020 as it will be called. I'm not sure if I may actually say that, but it won't be 12. It's 2020, and that will have options to build platoons without any scripting. And I'm not sure if that will be sufficient for what you need to model, because it's a kind of a simple way which doesn't model individual behavior of the vehicles, but basically just makes sure that the platoons are stable. But still, you might, for many projects, it might not be necessary to do any scripting anymore for platooning. And regarding the first one, RVC, it might be possible, I'm not sure, but it might be possible to copy the RVC DLL and RVC GUI DLL, those two, to a different name. I know, I think you need only to copy the RVC DLL, the one that is listed within the single controller as a GUI file or so. I think it's GUI file.
Supply file?
No, not supply, not program file, not supply file, but the third one. It should be GUI. GUI, is it? And maybe then you can call that and assign that to a different controller, and then you might no, sorry, that was wrong. Doesn't help you, because it's a modal dialog. Yeah, that's the issue. Okay, yeah. So for multiple controllers at once, you need multiple instances of Vissim at the moment. That's the only possible workaround. We are thinking about kind of taking the data model for fixed time and possibly BAP and possibly RVC back into Vissim, so it's not an external controller anymore, and then it would be available like in list windows, and you could have all that open in multiple views, but that's a lot of effort, and it doesn't look like we will do that in the near future.
Okay. Well, thank you, and thank you for staying up late and working late in Germany. I think we appreciate it.
All right, thanks again, Mike. We are going to move on to our final presenter, Gustavo. And Gustavo, it looks like your mic may not be turned on. So if you go under the audio tab, you can either switch to computer audio or internet.
Can you hear me?
Okay.
I can.
Yep,
Yeah.
we can.
You were hiding.
Yep.
Okay.
All right, looks like we've made you the presenter now. So, yep, we can see your screen.
Excellent. Well, thank you. Thank you very much for the opportunity. Our request here, we have a group of modelers here in Recondo, and basically we specialize in what we call airport landside simulation that has multiple components. Some of those are roadways, are not, but the thing that I want to focus today basically is the curbside operation. For the curbside, the places where vehicles drop off or pick up passengers at the terminals, it's a very unique element, and we have a lot of challenges and work around in order to make Vissim efficient and useful for this type of simulation. So our requests are basically involved in this area. Just to give you a little bit of context, the typical curbside behavior, you'll see that the distribution of vehicles parking. So by the way, we use parking zones and parking routes to model this in Vissim. The distribution is not homogeneous, so you have evenly or not evenly distributed based on what is happening inside the building, inside the terminal, whether it is departures, arrivals, security access, all that drives what's happening outside of the curb. So it's not a straightforward type of distribution. Also, it's very common, especially at busy airports, to see 2, 3, sometimes even 4 lanes being used, even though you may have only 1 lane marked for pickup or drop-off. That doesn't matter in terms of vehicles will park, will stop where they need to stop and drop off or pick up a passenger at those locations. There's significant interaction with pedestrians, whether it's pedestrian crossing or whether it's pedestrian activity on the curbside. Then there is the capacity is sort of a function of the parking capacity on the parking lanes, but also the through capacity is affected by all the disturbance being caused by vehicles maneuvering in and out of those lanes. So the layout of the curb is also important. We have many times it's a system of curves, so you have inner, middle, and outer lanes, and they are all connected, so vehicles can go in and out of these lanes, and that complicates even more what we do. So some of the issues that we face, and based on that, what we are proposing as potential features for this. So we have a lot. We have condensed this into basically 2 groups. One is related with curbside behavior, and the other is related with curbside or parking outputs. So starting with the parking behavior, one of the things, because we are so commonly using double or triple lane parking, the parking duration, or what we call the dwell times, the time the vehicle take to drop off or pick up a passenger, varies by lane, basically. So if you have vehicles parking on the inner lane of your curbside, they tend to stay longer. As they are double parking or triple parking, they stay to have a much shorter duration. The issue we have today is that parking duration is assigned to a parking routing decision. And what we would like to propose is if we can have the parking duration being a feature or a property, an attribute of the parking route or the parking zone. And in that way, we can assign different distributions for parking zones on the inner curve or on the second lane or on the third lane if needed. So this is one of the issues that we typically face that makes our models a lot more difficult to show a realistic condition. So another one, how you treat your through traffic on the curbside. So vehicles that are looking to park downstream, typically they will stay on your leftmost lanes. That's the typical behavior until the last minute. Once they see where they want to park, they will cross 1, 2, 3 lanes as needed to get to the spot, the parking spot that is, closest to their destination. So one of the issues that we see when we model this is the vehicles, because they know they need to park on a parking spot that is on lane number 1, they will try to start getting into those right lanes too soon, and then they get stuck with other vehicles that are either parked there or will park just before they park, and you can see here. This is just an example. Sorry, where these vehicles in the light blue here are searching. They have been assigned a parking spot, and that parking spot is further downstream on the on lane number 1. However, instead of using the left lane, which is open, they are stuck on lane number 2 here and not able to get to their destination. So what we're proposing is to add some sort of behavior option where vehicles will avoid lanes that have parking zones in them. So they will see a parking zone downstream, and if there is a lane that doesn't have a parking zone, they would prefer that lane, sort of stay on that lane until the last minute where they need to actually get into their assigned parking spot. The account for additional vehicle stages. So right now, in a parking zone, when a vehicle is parked, it will change the status and it will show the internal color of the vehicle in white. But we would like to see, other colors, so it shows the status of vehicles in different stages. Whether the vehicle is still searching for parking, whether the vehicle has finished its parking duration and now it can move because there's other vehicle blocking its exit. So it can change to a different color there, or whether a vehicle could not find a parking spot, and because the fuel occupancy behavior is set to wait, it's waiting until the next spot is available, or whether it could not find a spot and the behavior is set to drive on, so it will continue. That way, when we're looking at QA/QC in the model or reporting a result, we can see those different type of vehicles. Right now, it's very difficult to, unless you click on a vehicle, but on a glance to see whether a vehicle is waiting or is already stuck there or is searching. So that would be really useful for us if we can see in different colors the status of the vehicle. Another one, we have, and we requested this before, and it really helped us when you added that option for that attribute, fuel occupancy behavior, where vehicles, instead of just continuing when they don't find a spot, they can wait at a location where the next available spot is going to be, and just wait there. Now, This is good, but this is not enough, because sometimes the vehicle will wait there too long and create some queuing condition that is not realistic. So what we would like to propose is the ability to sort of assign a time distribution to the waiting vehicle. Once the vehicle is waiting, it will have a time distribution. If it reaches the end of that time, the vehicle will just continue and resume to whatever the former static route was. If it is before that, the end of that route, the vehicle will go to that spot and park there. The last one on behavior, I'm going to let Alex here, my coworker, to explain it.
Yeah, so when I was working on this modeling, I've got vehicles serving a terminal, and it's got multiple slip ramps in and out of the terminal. So I've got multiple static routes to the different exit slip ramps. Due to the exit of the airport being quite near to this, I really want to end those static routes as soon as I can and allow vehicles to start sorting themselves out to get out of the airport. The problem is that parking routes, if parking lots are available outside of the links on the static route, as long as Vissim can figure out a way for the vehicles to get back to the static route end, it will let vehicles park. It will let them leave links that are on the static route and go park. So what I'm having here is Vissim is seeing that some parking lots are available that are beyond the exit link that it needs, and they're going and parking, and then they're recirculating around. And as they come back in, they get a new parking spot from the parking route. And so then this can be like an indefinite loop unless they get a parking spot that happens to allow them to exit through their desired slip ramp. So just maybe including an option in the parking routes to say, ignore all parking that's not on your links for your static route, something to that effect.
Thank you, Alex. Gonna go quick on this last batch of ideas. So showing here basically what we use to characterize the operation on a curbside. We use a level of service criteria that is based on parking utilization. And so we basically looking at the utilization of each lane, and based on that we decide whether different levels will generate different level of service. So this is one thing that we do, that basically right now we're using data collection points that we put upstream or downstream of every parking zone. And with that, we collect every 30 seconds or every minute how many vehicles in and vehicles out. And based on that, we calculate the utilization. So this is a lot of data and coding intensive, labor intensive, that I think it would be also if we just get some outputs from the parking. So what we are basically proposing here is to just have, average parking occupancy and have the ability to report that the same way that we have on roadways. We have sub-segments and we have the whole link. So if we can have by parking spot, by parking zone, or the ability to group certain parking zones and generate the output by vehicle class or vehicle type, and also sort of create a heat map. What you're seeing here is the heat map created using density as a proxy for for parking occupancy, and using the sub-segment, which is very close to the average parking spot length. Now this is not perfect, so if this thing would just produce or report the spot density or the spot occupancy, then this can be done in a much better way. average volume for parking, heavy parking zone, average time that vehicles were blocked, number of vehicles not able to find an empty spot, average dwell time by spot, by zone, and this might be a stretch, queue length upstream of parking zones. So basically, that's the kind of thing we're looking in terms of outputs from parking. We have more, but in the interest of time, we're just going to stop here. And just, if you have any questions. But again, thank you so much for the opportunity to be part of this and show you, what we do and what we need, and listen.
All right, thank you very much, Gustavo. I'll pass it over quickly to our product management team if any follow-up questions.
Well, there are lots of nice ideas, so I hope we will get all your presentations so we can further look into those. And we have a generic issue for parking lot evaluation on our list, and it's really nice to have these details here you showed us, so we know what exactly might be useful. But well, there's no scheduled development time for that yet, but we'll see. And yeah, I don't think, are there any questions?
No. Very well presented. I think we got it, got the idea. Yeah.
Okay, well, thank you.
Yeah, thank you.
All right, we got to the end of today's session. Thank you to all presenters. We will get back to each presenter with feedback or status update followed by this session. But before we let you go, we have a few announcements. Today's recording will be available, and you will receive a link tomorrow in the follow-up email. And as always, you will find this and other presentations at www.ptvtraffic.us under the Resources tab. Our next session is on May 23rd, when we will be showcasing some of the presentations that were given at our last year's user group meetings. It will give you a chance to see what types of presentations are given at our UGM. Please make sure to watch your emails and PTV America LinkedIn page for a link to register.
Also, remember to mark your calendars. Our 2019 UGM will be October 9th and 10th in New Orleans, Louisiana. We will also be celebrating our 40th year of PTV and the 20th annual user group meeting. So if you'd like to get a chance to participate, make sure to plan ahead. That's all for today. Again, thank you for all your participation, and see you again in 2 weeks at our next PTV Talks. Have a great rest of the day.